So we're looking at a few questions here where we want to simplify and express the following as mixed radicals in lowest terms. What that means is that we want to simplify as much as possible the radicand, which is the number underneath the square root sign. So let's look at our first one. We have the square root of 72. What I'm always trying to look for in every case when I want to simplify something like this are perfect square factors. So in this case, I know 72 is, if I want to break it down, the product of 2 and 36. The reason why I chose 36 is because 36 is a perfect square. So if I break this up, I'm actually going to put the 36 first and then the root 2. I end up with 6 root 2. And the root 2 can't be simplified further, so you are done. For B, I have a square root of 27, and I know that 27 has a factor of 9. And again, I'm choosing 9 because I know it is a perfect square factor. So I'm going to break up this root here into, not root 6, but root 9. Sorry, root 9 and root 3. And the square root of 9 is equal to 3. So I have negative 6 times 3 times root 3. So my final answer is negative 18 root 3. For C, I have 2 times root 10. Now, root 10 and root 2 do not have any perfect squares as factors, but if I rewrite my root 10 as root 2 times 5 and break it up, so I have root 2 times the square root of 5. Well, this here, I'll go back a step just so you can see what it results in. If I combine it together, I get the square root of 2 times 2. And that's times the square root of 5 again. You know what, I'm going to drop out that middle one. And the square root of 2 times 2 is the square root of 4, root 5. And now we have the 4 as a perfect square factor, which gives me 2 root 5. So in this question here, it's advisable to, even if you don't have a perfect square as a factor, try to decompose the number and see if you can just maybe match up pairs of numbers. Okay, I was reading ahead with anticipation of seeing the 2's underneath the root sign, and I knew that if combined, they would give me 4. Now on to D, it's the same thing. Okay, neither 2 nor 6 nor 3 have perfect square factors, but I know that 6 can be broken down in such a way that I get the square root of 2 times the square root of 3. And I'm jumping a step here. Hopefully you spotted it out, but this here, these two guys, that's what gives me the root 6. And the root 2's combined together give me root 4 times root 9, which equals 2 times 3, which equals 6. Moving on. Here I have 2 mixed radicals. So I have 4 root 3. There is nothing I can do here, times 3. And I'm going to write the root 6 as root 3 times root 2. And again, my rationale, my motivation for that is the root 3 and the root 3. I know combined together, they will give me the square root of 9. So let me put all the numeric parts, the whole number parts in front. Then I get a root 3, and a root 2. In between these, the operation is multiplication, but of course we never write the dot. So here I get 4 and 3 gives me 12, root 3 and root 3 gives me root 9, and then root 2. The square root of 9 is 3, so I get 12 times 3, root 2, and so my final answer is 36, the square root of 2. And finally, for our last one for F here, same idea. I'm going to decompose this 10. I know that 10 has a factor of 5, which, lo and behold, is similar to, well, same as this one here. So I have 2 root 5 times negative 3, root 5, root 2. Again, 5 and 2 are the two numbers that give me 10. And I'm going to rearrange here. So I'll bring all my coefficients to the front. So then I have a root 5, root 2, and that leaves me with negative 6, root 25, root 2, which is negative 6. Again, the square root of 25 is 5. The square root of 2. Final answer, negative 30, root 2. So there you have all these examples worked out for you.